study of astronomy has been really more of a story than anything else from the beginning. So, once upon a time, because that's the way a good story should start, people would stand, and they would stand on the ground, and they would look up in the sky and see stars. And some of them thought, why does this really matter? But others would try to use them for figuring out where they were going, for sailing, for any sort of sense of direction, or even for just understanding what's going on, keeping track of time, maybe how their local systems would play out. So from very early on, we as people have looked up at the sky and thought, huh? Over time, we came up with different models. So an early model said, what I see is that I'm standing on the ground, which is flat, and I look at the sky, and I notice that these patterns of stars, they kind of stay the same. They move around some, but maybe the orientation of some of these stars is the same. So we said, okay, of course what's going on is that there are stars in this kind of half sphere, and that rotates, and so we see these stars that repeat over and over again over time. This was based on the idea of what we call a geocentric model. Geo meaning Earth, centric being in the middle. So this is a model that put the Earth in the middle. So we said, what are we going to do with this? Well, great, stars. However, there were some objects in the night sky that weren't stars, that we recognized very early on weren't stars, and they were different planets. Didn't necessarily know what those were. We just thought, oh, these are wandering stars. They're stars that move against the background of stars. When we would look up at the sky, we would see many stars that would just kind of stay put. But then we would also see a couple of things that over the course of the year might move around a little bit. So this one might appear here one night, but over the course of the year kind of migrate in the sky. This one might appear here, but over the course of the year might kind of migrate in the sky, where these other stars would stay relatively stationary against each other. So we said, alright, there's something else going on with these moving stars. So maybe we need a more complicated model versus just this whole half sphere thing that rotates around. So we came up with a more complicated model. We said, what's going on? Well, we are the Earth. Of course, the Earth has to be at the center. We've seen the moon. The moon moves around the Earth. And that makes sense. But then some of those other dots, these red dots, blue dots, we saw this thing that would also move around the Earth. And then we would see maybe another one that would also move around the Earth. And we get kind of this model that consists of different spheres, different orbits of objects that move around the Earth. And that made sense, because as these rotate, we would see the motion of those objects in the sky. But there are also the background objects that stay put. Those stars that we were talking about, these white stars, those stay put. So it must be that those exist out here beyond the circles. And so we have a nice geocentric model. Earth is at the center, where of course it should be. Everything moves around it. That makes sense. Except for these stars that look like they're the same night after night. So that works. Maybe even these stars rotate slowly so that we can see the constellations and stuff move around in the sky throughout the year. Well, that was good. Except then we realized when we are looking up at the sky, over the course of the year, some of those stars that we saw, not the stationary stars, those were fine. But some of the other things that we saw, this guy moves this way, this way. Hey, this is all making a lot of sense. Uh-oh. That doesn't make sense. Okay, now it's moving forward again. This is tracing out the path of this moving star over the course of a year. Well, that doesn't make much sense. How does that work with this circle that's moving around us? That's no good. So we need a more complicated model again. So here we go. Maybe for that particular moving star, as a little bit of a spoiler, the moving stars we will later find out are planets. For that particular one, maybe what's going on is instead of having a nice smooth circle, so some of these are nice smooth circles, like the moon, but maybe for some of them, what we have is a general circular path but instead of moving along that, and this would kind of make sense, because depending on how many times we spiral, we could see that planet moving across the sky, turn back, start moving forward again, and we would call this a retrograde orbit. This was particularly convenient for blaming your problems on. What's going on? Well, this planet's in retrograde, so the world doesn't make sense this week. Retrograde orbits are a way of explaining what we see is the apparent motion of that planet moving forward, doubling back, moving forward, doubling back. It's a way of representing that motion with the assumption that we are at the center. But then things got really weird, because we said collectively, what if we're missing something? What if instead of the Earth being at the center, what if we're not? What if this thing could be a lot better represented by saying, here's the Earth, here's the sun, and we aren't at the center. Instead, we move around the sun. We can still have the moon move around us. But if we move around the sun, and if these other planets move around the sun, then we get a nice explanation for a system, because that predicts that back and forth motion. Because now it looks like, from where we're standing, this guy moves forward at some points, but then at this point it looks like it would be moving backwards against the sky. Right? We would see from our perspective, right here, this planet's moving kind of upward, but then once it gets past a certain point, now it's moving kind of downward. And then once it gets here, it's moving kind of upward again, because we see just kind of a flat projection of this. So this makes sense. Now we've got a model that accounts for the goofy motion of some of those planets. We also still have the stars, but if these stars are way out here, far away, then those wouldn't really move. Actually, most of our problems are solved by saying the sun, most of our astronomical problems, are solved by saying the sun, not the Earth, is at the center. So when the sun is at the center, we call this a heliocentric model. From there, we went on and said, maybe our solar system is not the only thing going on. Maybe all these extra stars out here have things going on too. And then we get into the more complicated models where we say, let's take our whole solar system, shrink it down, and maybe there are more solar systems. And some of these have stars, or have planets around them. Some of them don't. Some of them come in pairs and make binary star systems. Maybe you have other things around these as well. And now we see that our little solar system, we can back out and back out and back out, and there are many, many stars, some of which have planets, some of which don't. What we learned then is we can keep backing up. And really, a lot of the remainder of our journey in astronomy has been, we are not backed out far enough. As we back out more and more, these stars and the dust around them and everything starts to form together to be part of this big spiral. And we end up with a galaxy. A large spiraling galaxy, as it turns out. And then we do some modeling, and we find that that there must be something pretty wild going on at the center of that galaxy. But that here's our sun, and everything that we've ever studied in the entirety of history falls right there, around our sun, which is only part of some galaxy. We zoom out more and more, and we find that our galaxy is one of many galaxies. So now these are all just different galaxies. They don't all have the same shape, but each one of these is a galaxy. And that these galaxies together are called we can call a galactic cluster. We zoom out more still, and we find that there are many clusters of galaxies. We call those superclusters. And that the rest of our journey in astronomy is all about how far can we zoom out. So where we started all the way back with a simple question, we move our way forward and forward and forward, and outward and outward and outward. And the remainder of this course will be about that journey outward and about seeing just what we can discover as we let our view of the universe grow.